Hello, everyone. What are you guys doing today? So, we are in our last class before our third exam, and I'm going to tell you at the end of the class what exactly to expect in the exam. And then we are going to go on a vacation. Yay! But I want to grade all of your exam. I'm giving exam to 2 of my classes. It's around 50 exams. No, 30, 60, around 60 exams. Yeah. And if each has 4 pages, then 60 times 4, 6 times 4 is 24, around 240 pages. Oh man, I hate that. Exam, I'm talking about the how many exams I have to grade in the vacation. Okay, anyway, so in our last class, we did 7.3, 7.4, where we talked about adding and subtracting rational expression. So what's the requirement to add or subtract rational? What do you need? Same denominator. Good job. So we learned some trick how to find the same denominator. LCD, one of the trick was if you cannot divide one denominator by another denominator, just multiply them. That will be LCD. So we start with finding LCD. What is the LCD in this question? We have x plus 3, x minus 1. What's the LCD between them? Can you divide x plus 3 by x minus 1? We cannot. So what's the LCD? They're products, just multiply them. Huh? X plus 3, we cannot divide by x minus 1 because they are not same thing. If we cannot divide, then multiply them. That should be LCD. X squared and 3. What is x squared and 3? No, it's FOIL, but you don't have to do any foiling. You just have to find what is your LCD. What is the same denominator you want on every denominator? We want these two to be on every denominator. So on the first denominator, we have x plus 3. What we don't have? X minus 1. So we multiply numerator and denominator by x minus 1. And now second denominator only has x minus 1. So what we don't have in our second denominator? So we want to put x plus 3 here. So we multiply numerator and denominator by that. So step 1, find LCD. Let me write down the step here. Steps. So we have to pick a number either on the bottom or only the denominator. LCD means the denominator. You look at the denominator and you decide what you want to have in every denominator. So the first denominator has x plus 3, second denominator has x minus 1. How can I write this? Find LCD. So how do you find LCD? We did many examples in our last class. So I am doing it step by step. I'm doing the right page. Find LCD. To find LCD, you look at the denominator. What denominator we have originally? X plus 3 and x minus 1. So what's the LCD? Means least common denominator. Means the same denominator you want on every denominator. So we want all of them to be on the same denominator. So first denominator is x plus 3. We want that on the second denominator. Second denominator has x minus 1. We want that on the first denominator. Why? Because then if you observe the denominators, they all are same. So the first one did not have x minus 1. So we multiplied both numerator Numerator and denominator, come on, by that x minus 1. The second denominator doesn't have x minus 1, so we multiply numerator and denominator by x plus 3. So the second step we did was to multiply, let me write top and bottom to make it shorter. Multiply top and bottom by what is missing. The first numerator is missing the second denominator. First denominator is missing the second denominator, so multiply top and bottom. The second denominator is missing the first denominator, so multiply top and bottom. Now, third step, once you have the same denominator, keep bottom ones and combine all the top. So first numerator is x minus 1 times 2x minus 4. And this time we are subtracting. Our second numerator is x plus 3 multiplied by 5. So this is our step 1. This is our step 2. Then fourth is simplify the top. Means do whatever you need to do to simplify your numerator. So we start by distributing. X times 2x, what do you get? 2x squared. Then we multiply the next one, x times negative 4. Negative 4x. Then we go negative 1 times 2x. Negative 2x. Lastly, negative 1 times negative 4. Positive 4. So we distributed the first numerator. We are going to do the same thing on the second numerator. We have negative 5 times x, negative 5x, and negative 5 times 3, negative 15. Don't forget to write your denominators. We have x plus 3 and x minus 1. But we still are not done with simplifying, so we have to keep simplifying by combining like terms. We have 4x, 2x, and 5x. They are like terms, so we're going to combine them. Then we have 4 and 15 like terms, so we need to combine them. Do you see any extra x squared besides 2x squared? So we keep our 2x squared. There is no more extra. And if you add all the yellow x's, how many x's you get? Minus 4, minus 2, minus 5 is? Good. And if you combine all the green numbers, plus 4 minus 15, negative 11. And we keep our denominator, x plus 3, x minus 1. So we simplified the denominator. And then we have to check the numerator whether it's factorable or not. This time it's not factorable. So if you want to check, you have to use the AC method. A times C is 2 times negative 11. That gives us negative 22.
Can you explain how you got the lowest common denominator again?
Let me finish AC and then I'll tell you.
Okay.
So the AC, multiply A with the C, 2 times negative 11, I get negative 22. What factors we get for negative 22? One of them is definitely 1 and 22, right? If we add them, what do you get? 23. If we add them, what do you get? 23. If we subtract them, we get 21. But how much we are looking for in the middle? So 1 and 22, will they work? No. And what is the other two factors? 2 times 11. How much is 2 plus 11? And 2 minus 11. But we are looking for how much? 11. So is it factorable? So we stop. This is our only answer. Now, Daniel, to find LCD, depending on what you have, we find LCD differently. So let me refresh your memory about LCD. Insert LCD. What's the LCD between 2 and 3? How do you know? We multiply them. So what do we do? What did we do is we try to divide 2 by 3. Can you divide 3 by 2? If you cannot divide, you just multiply them. How about LCD between 2 and 4? How do you know? When you try to divide 4 by 2, it is divisible. If you have something divisible, the answer is a bigger one. So between 2 and 4, 4 is bigger, so we have 4. So this is what we do for numbers, for smaller numbers. For variables, the same concept. Remember the word, LCD means big. So if you have x and x squared, what is your LCD? Means which one is big? So LCD is x squared. If you have, let's say, x squared and x to the 10, what is the LCD? X to the 10, because this is bigger. LCD means you're looking for something big. Okay, now if I give you x plus 1 and x plus 1, let's say cube power, what's the LCD? You observe do you have the same denominator? Not denominator, sorry, same base. This base is x plus 1, this base is x plus 1. Do you have the same base? If you have same base, then what is the LCD? The bigger power. See, this concept is here. If you have same base, you have to take the bigger power as your LCD. We have the same base, so LCD must be the bigger power. X plus 1 with a cube. Now let's see, you have x plus 1 and x minus 1. Now what's the LCD? Both of them. X plus 1, x minus 1. Don't try to multiply them, just take them.
If it's not, if it's a bit, something like that, you have to take both.
Just take both. Now, if I tell you compare x plus 1, x minus 1 in one group, and in the other group, you have x minus 1 with a square. Now what happens? In this group, so this is x minus 1 and this is x plus 1. So in this group, we have two different things, right? Plus 1, minus 1. We must take both of them, x plus 1, x minus 1. Definitely, because they both are new. Take them. Now, if you compare this and this, do we have the same base? So if you have same base, how many powers you have to take? The smaller one or the bigger one? Bigger one. So we have to do x minus 1 with a 2 power. X plus 1 is only one of them, so we take only one. But comparing these two, we have same thing, 1 power and 2 powers. So our winner is a 2 power. That's how we find LCD. We compare them. If they are different, take all. If they are same, take the bigger one. It's like selfish person, you know? The selfish person wants to take everything for themselves, and also they want to take the bigger one, not the smaller one. So LCD is selfish.
Can you explain the bigger one, the smaller one? What do you mean by that?
If you have the same base, so we have 1 power here and we have 2 power here. Which power is bigger? So you take the bigger one. Same scenario here. X plus 1 has invisible 1 power and visible 3 power. Which one is bigger? 3 power. So take the 3 one. The last one, we have x minus 1 with an invisible 1 and x minus 1 with a visible 2. Which one is bigger?
2.
So you have to take the 2 power.
So how do you explain the 2 component?
Number and variable are different. For numbers, if you cannot multiply, if you cannot divide, multiply them. For variable, if you cannot, again, divide, they're the same thing actually. If you cannot divide, multiply them. If you can divide, the bigger one. So between x minus 1 square and x minus 1, this is divisible because you have the same base. That means take the bigger one. But if you look at this one, if you try to divide x plus 1 by x minus 1, can you divide? They're different. So multiply them. Not divisible, multiply them. Is divisible, the bigger power. Now, based on this concept, let's do something like this one. We have x over x squared minus 25, and you're subtracting 2 over x squared minus 10x plus 25. Can you guess what is our first step before you even go for LCD? Good job. Factor denominator if possible. The other examples we did, if you observe, let me go through real quick. All these examples we did, none of them were factorable. So we didn't do this factoring part. But anytime you have something that is factorable in the denominator, we don't care about the numerator, okay? Fraction is always about denominator. It gets the priority. So look at the denominator, and it's factorable. Oh, factor.
Can I do that first?
Good job. Go ahead.
Okay. So in the bottom will be x negative 5
X plus 5.
and x.
Good. So this is difference of perfect square. How about second denominator? Nayari? X minus 5, x minus 5. So we did direct factor. So 3 terms means direct factoring, AC or trial. 2 terms means either difference of perfect square or GCF. Okay, now let's compare. We have x plus 5, x minus 5. Are they same or they're different? So you have to take both of them. And now if you compare this x minus 5 with this x minus 5, we have 2 of them in the second one and 1 of them in the first one. So how many are you supposed to take? 2, bigger one. This is same as this example. If you see 1 in one group and 2 in other group, you have to take the 2 one, the bigger one. Remember I said LCD is selfish. It takes big, it takes everything. So from the first one, it takes everything, but the first one and second one, there's something in common, x minus 5. So if you observe x minus 5, we have 2 of them here, 1 of them here. We need to take 2 of them. So if this is easier for you, you can write this as x minus 5 squared. And then you can compare this square. And let me erase this highlighted. So compare x minus 5 and x minus 5 squared. Square is the winner. Take that.
Can you just keep it as x minus 5?
Times x minus 5.
If you can't keep it the x.
Sure. You can keep both of them instead of writing square. But which one will take less time? Writing it 2 or writing same thing twice? Okay. In the exam, you may not get enough time to write everything in detail, so try to use all the shortcuts. Okay, so we did our first step, factoring, and second step, the hardest part, LCD. We found our LCD. Once you have a LCD, what do you want? All the denominators to have what? Your LCD. See the step? Find LCD, we found it. The second step is multiply top and bottom by what is missing. In the first denominator, we have x plus 5, x minus 5. But our LCD says how many x minus 5 we want? 2 of them. So are we missing anything on the first denominator? What is missing? One more x minus 5. So let's squeeze it here. X minus 5, x minus 5. Multiply top and bottom by whatever you need. We need one more x minus 5, so multiply that. Now, second denominator has x minus 5, 2 of them. But what is missing here? That x plus 5. So let me squeeze it here. X plus 5, x plus 5. It's 5. And now we are happy. We have x plus 5, x minus 5, 2 of them. X plus 5, x minus 5, 2 of them. So both denominators have the same thing. We ignored them. We write it once. And what do we do with the numerators? We have the first numerator minus second numerator. So let's write them. X times x minus 5 minus 2 times x plus 5. Try to write this out. If you do, then you can see that the subtraction will change the sign. Okay, so what do you get from the distribution of the first numerator? X squared minus 5x minus 2x minus 10. And we have our x plus 5 and x minus 5 squared. And it is this. The last step says simplify the numerator. So do you have anything to simplify on the numerator? Anything to combine or anything? So x squared, how many x's we get? Negative 7x minus 10. And we have x plus 5 and x minus 5, 2 of them. And then you have to check, is the numerator factorable or not? So can you think of two numbers, multiply to negative 10, but add up to negative 7? 2 and 5. Give me their sign. Negative 5 positive 2 gonna give you negative 3. So negative 5 plus 2 is negative 3, but you're looking for negative 7. So if you're thinking about negative 5, negative 2, good is negative 7. But if you multiply negative 5, negative 2, what do you get? Positive 10. But which 10 we have? So is it factorable? So you stop. You should always check whether it's factorable or not. And that's how we do addition subtraction. And you're done with addition subtraction. The next chapter is 7.5. It's same as addition subtraction plus 2 things extra. The 2 extra things are, once we have this simplified form, we take the numerator, something equals to 0, solve for x. If it's solvable. This is the first step. Second step, You take the denominator and see what makes the denominator 0. We cannot have them in our solution. So denominator tells us what we cannot have in the solutions, and numerator tells us what is the solution. That's it. Two things extra. So we call them solving rationale. Can I flip my page twice? Okay. Let me skip this page. So what did I tell you when you see the word solve? What do you want to see in one side of the equal sign? Anytime they're asking to solve something, what do you want to have on the one side of the equal sign? 0. Good job, Mara. Solve automatically means 0. Anytime they're asking you to solve something, most of the time we want to see 0 on one side. Do you see 0 in one side? So what do you think our first step should be? Bring that thingy from right to the left. So we have 3 minus 8 over x plus 4 over x squared equals 0. We cannot combine them because none of them are like terms. They all are different things. So you cannot actually add them or subtract them. And I wrote this way because I want to increasing order, no x, 1x, 2x. So if you have them in increasing order, it will be easier for us to factor at the end. We didn't have to have the order correct. It's fine. So now you're going to ignore the 0 and you're going to simplify our left side. So we need our LCD. What's the LCD between x and x squared? Good. If you have same base, then we must take higher power. So LCD is x squared. That means we want this x squared on every denominator. Below 3, do you have x squared? So you put it here. But if you put it here, what do you have to do with that 3? Multiply by x squared. So these are second step of factoring. Not factoring, sorry. Addition, subtraction. So the first step was find LCD. We did that. Second step, multiply top and bottom by the missing piece so that you can have the LCD on every denominator. Now, the second denominator has x, but we want x squared. So what can you multiply this x by? Another x. And you do it with numerator and denominator. The third denominator, do we have x squared in there? So do we need to do anything? We already have what you want. So do you need anything extra? No. If you already have what you desire, we don't have to do anything because you already have everything. But if you don't have anything, then you multiply by something to have what you desire. The first 3 doesn't have any denominator, so we put the x squared on the denominator and we multiply the numerator by that. Second denominator has only x, but we want x squared, so we need something extra. So we multiply by this extra x, numerator and denominator. And the third one already has what we want, so ignore. So we have our LCD, then we go and combine all the numerators. So we have 3x squared minus 8x plus 4 equals 0. And then you look for factors. Is the numerator factorable? Let me do it here. We have 3x squared minus 8x plus 4. Is it factorable? Which method do you have to use to see if it's factorable or not? Good job, AC. Anytime you have your A, it's AC. So A times C is 12. So let's see the weird method. X squared minus 8x plus 12 Can you think of two numbers multiplied to 12 combined to 8? 6 and 2. Give me the sign. 6 must be what? Negative. And if you want to get 8, what sign 2 has to have? Negative 6 plus 8 is 4. You have negative 6 and you have 2. You want to get negative 8. You have to have a negative. That means the numerator is factorable, but we are not done, right? It is AC method, but we are. So what is our A again?
So we have to divide
Which one we divide by 3?
6.
6. And then this one we multiply. Why my sign is missing? Once you find two factors by direct factoring, one of them definitely will be divisible by A. So whichever is divisible, it divides by A. And whichever is not divisible, you multiply that variable by A. So that means what is our final two factors we have? X minus 2 and 3x minus 2. And with this, we are done with addition subtraction. And now we are going to go to the solving part. So solve starts from here. We take the numerator equals 0. Just in question or stretching? So our numerator is x minus 2 and 3x minus 2. We set it equals to 0. And this is same as what you did in chapter 6. What do you do after that? But before that, you have to set them individually to the 0. 3x minus 2, 0. And then we solve them individually. Add 2, add 2, add 2, add 2. So x equals 2, simple. We don't have to do anything, stop. But this one is 3x equals 2. So I divide by 3. So x equals 2 over 3.
And what happens to the extra in the denominator?
Now it's coming. So numerator gives a solution. So our solution is x equals 2 and 2/3. But we also have to check. We have to be careful about the denominator. What makes the denominator 0? We cannot have them in the solution. So we look for our denominator is x squared. If we don't want the x squared to be 0, then x cannot be what number? What makes the denominator 0? X equals what? 0. So we don't have this 0 in our solution, but if we do have this 0 in our solution, you have to disregard that. So same as addition, subtraction, and then two extra things. Numerator gives us solution. Denominator tells us what we cannot have in the solution. So we cannot have 0 in our solution. In reality, if you follow my method, first add, subtract by bringing everything to one side, you don't even have to worry about the denominator. Okay? But if you don't follow my method, if you get rid of the denominator from the beginning and then work with the rest, then you have to be careful about the denominator. So this can be done in many other ways, okay? But I found this is the best way you can do without worrying about the denominator. Let's try a few more. Try this one by yourself. Solve. I might say that one, but and since I did not take the attendance yesterday, I'm going to take it today or yesterday. Sheikh, you were absent yesterday. Yeah, I remember. Christian was here yesterday, not here today. Christina, here both days. Christopher, here both days. You're here yesterday, right, Christopher? Or were you here yesterday? Danielle, absent yesterday, present today. I'm trying to visualize yesterday's scenario, the classroom, whom I saw and whom I did not see. Devalat, absent both days. Dennis, not here today, but was here yesterday. Idaliz was here yesterday, but not here today. No, her name is Taj. I'm learning your name, guys. Jay, you were here yesterday, right? Joshua, present both days. Justin, present both days. Kathleen, you were absent yesterday. Kelly, present both days. I remember you came late yesterday. Kyle, you came late yesterday, right? No? On time. Lady was here yesterday, not here today. Muntaha. Were you here yesterday, Muntaha? Yeah. I was like, I can remember her face. So yeah, I didn't see you. Nayari was here. Nayari, just a warning. Next class, when you come to take the exam, sit in the front. I don't want other people to cheat from you. I had this in my mind yesterday, but I'm just telling you today. Nicholas I, here both days. Nicholas S, here both days. RST, here both days. Rana, here both days. If you're done, there is one more. Ricardo, you are here yesterday, Ricardo, right? Taj, here both days. Mora, always here. Zichi, absent both days. Okay. So one more question. Go ahead, guys, try it.
No, this is the thing.
So I'm learning that like the way you like doing it and I'm like writing. I'm not I'm gonna watch it. See how that works. I'm
Good, but see, these are in wrong order. So first write them in correct order. And then you can start using it. You can bring everything to one side. So that's I had everything to one side, so I can each one side. This one is just one. It is in German. It is in German. It is in German. I think it is. Okay, so we have this 1 over x, like 1 over x. Then you have plus 1 by plus 1. Then you subtract it, is the 2 over x squared, so that's the neutral. You're moving this from right to the left. Why are you subtracting this one? So you're subtracting this. 7 squared from both sides. I want to I want to have access to the Google site. Equals to what? Good, so step one is always bring everything to one side. So you don't have to do this minus. Keep your left, then subtract your right. Okay, now what is your significant compare x and y? So I got it in big line instead. Yeah, minute time. Now we have x, but you want x squared. So what do you have to multiply by? You have x, but you want your x squared. So you can multiply this x by what? Only one times x is x. X times what is x squared? But you don't have x squared, you have x. X times x squared is x cubed. We can times by something, so the result you want two of them. So one is multiply by x times y is x. X times x squared is x cubed. Times what is x squared? Being knows. So 1 plus 1 is 2 of them. That we give it to multiply by x. But this one doesn't have one x squared, so it's round about. Why are multiplying by x here? Do not try to understand the concept. Our step one is seeing a zero. Do you see a zero? No. So you subtract it with 0. When you subtracted this from the LCD, I took out the LCD, I rewrote. So erase this line and rewrite everything what you see. This minus that, write that. And then what else? Did you do that? I did not. Do not use that guy. If you do that, here you go. Let's do together into the next time.
Okay, so I have a question. So same. Like when you find
The denominator doesn't become 1, the denominator becomes the LCD.
like here, yeah, right there. So you put.
So look, first step I subtracted and then I rewrote what I have.
Yeah, like I meant like
Once
one,
I
like,
rewrote, then I went for LCD.
Yeah.
So when you look for LCD, all the denominators are same, right?
Yeah.
So you write only once, not one, but
Yeah,
once.
that's what I meant. I meant like it becomes the X squared.
One of them.
Yeah.
And then you combine all the numerators. So see, I did step by step. I use different color for different steps. So do not try copying the solution step. Copying the, try to understand the steps. Step 1, bring everything to one side. Step 2, look for the LCD. Step 3, once you have your LCD, multiply top and bottom by the missing piece. Okay? Once you multiply, then our goal is to do factoring. So observe what I'm doing. I don't see a 0. That means I need to subtract this from right to the left. So 1 over x plus 1 minus 72 over x squared equals 0. I rewrote my first line by bringing the right to the left. And then step 2, look for the LCD. What's the LCD between x and x squared? Only x? X squared. Step 3, match all the denominators. So first denominator has x, but we want x squared. So what do you have to multiply by? X. So we multiply numerator and denominator, both of them. The second expression, the second term is 1. We want below 1 and x squared. So you have to multiply the 1 by x squared. The third denominator already has an x squared. So do you want anything extra there? So ignore. Once you have all the denominators same, combine the numerator. So see, I first wrote my LCD separately on the next line. And now all I have to do is combine the numerators.
On the left side, numerator over the whole numerator.
This is not numerator over, this is numerator equals 0. It's a step. What I'm doing, step, numerator equals 0. Numerator equals 0. Okay. So I took the numerator and set it equals to 0. Okay, so anyway, so once I have all the denominators same, I look for numerators. The first numerator is x, then we have plus x squared, then we have minus 72 equals 0. But doesn't it look weird? X squared. So what do? We rewrite x squared first, x in the middle, and 72 at the end. We did that because what is our goal? Factor. So can you think of two numbers, multiply to 72, combine to 1, Nicholas? Positive 9, negative 8. With this, we are finally done with addition and subtraction. So we simplify our addition and subtraction, we are done. And now we are going to go solve. So solving has two things, numerator and denominator. It actually has only one thing, numerator. If you did my way, by combining all of them, then you have to worry about the denominator. So you only can look for numerator. if you follow my rule, okay? If you don't, then you have to do both numerator and denominator. We take this numerator and we set each of them to be 0. X plus 9 equals 0. X minus 8 equals 0. So we subtract 9, add 8, add 8. Anyway, so we have X equals minus 9 from here. And from here, we have X equals positive 8.
Do you have to write x squared doesn't equal 0 and x doesn't equal 0?
If you follow this method, then you don't have to. Because that denominator already is taken care of here.
So I just write it like that.
So if you remember, our goal is to first add subtract. In this add subtraction, every denominator problem will be solved here. If you have some problem that makes the denominator 0, you will be able to cancel. So if you follow this rule, I'm telling you guys again and again, if you simplify fast, then don't worry about the denominator. Your numerator tells you the answer. But if you don't follow this method, you follow other method, then you have to follow the denominator. You have to see what makes the denominator 0. I'm warning you, in the exam, I'm giving you something that will make the denominator 0. So if you don't follow my method, you get the wrong answer. The next one is same as the last one. Bring everything to one side, but luckily they already gave us everything to one side. So you don't have to do the first step. We go for LCD directly. And all of these, they have the same LCD. What's the LCD between x and x squared? X squared. See, I'm writing it separately. Do it my way, exactly the other way I'm doing. Make a line, and the denominator is your LCD. And now match the denominators. What we want here, x squared. So you multiply numerator and denominator by that. What we want here, x squared, so you need to multiply by x. So top and bottom. Do we have x squared on the third one? So do we need to do anything? No. So we match all the denominators. Now we look for the numerator. What do we have on the numerator? 2x minus 3 equals 0.
You have to show your second.
You should. Trust me, I'm doing all of this for your own good. If you try doing everything mentally, you're going to make mistakes. And now our goal is to factor. So we have 5x squared plus 2x minus 3. So x squared plus 2x, what is our AC? 15. So is this factorable? Two numbers multiply to 15 combine to 2. Negative, positive 5, negative 3. Now, which of these is divisible by a? So we divide this by 5. And what do we do in the other factor? Multiply only x by 5. Not the entire expression, only x by 5. So what factors we got from these? X plus 1 and 5x minus 3. And since you followed my rule, my method, you simplified everything. So your life is easy. All you have to do is take this and then you are done. X plus 1, 0, 5x minus 3, 0. So what is x? Negative 1. So we add 3, 5x is 3. So what is x? 3/5. Where did you get lost? So did you understand the AC method?
Yes.
So this is weird. This is weird AC method.
Okay,
This is not the normal AC method. The normal AC method is grouping. I did not use grouping, I used weird. In this weird method, what I did, I wrote x squared this, and instead of writing 3, I wrote 8c. 8 times c is 15, so we write negative 15 here. The good side about this is that this is directly factorable. So you have to use AC method to factor this. 3 times 5 is 15, 5 minus 3 is 2, so we have plus 5 minus 3. Then you bring your A. This A, one of these is divisible by A. 5 is divisible by A, so divide by A. 3 is not divisible by A, so multiply the variable by A. That means we get x plus 1 after the division, and this is 5x minus 3. These are the two factors you're supposed to get if you use the normal AC method, the grouping AC method. After that, you just look at the numerator. Just forget about the denominator.
So you separate them, like x plus 1, 0,
X plus 1 equals 0, 5x minus 3 equals 0.
Okay.
Solve all of them individually.
So then the result is forget about x squared.
If you simplify here, then don't worry about x squared. But if you don't, remember, this can be done in many different ways. So if you don't do this method, then you have to look for your denominator. What makes the denominator 0? But I'm making your life easier by bringing everything to one side, so simplifying everything, and then just whatever the numerator.
You keep saying the denominator zero. What happens to the denominator zero?
Then you cannot have it in a solution.
Like, what's no solution?
Whatever you have that doesn't make the denominator 0, the rest are the solution. For the same question, did I make a mistake anywhere? Positive 5, no, then yeah. If this is correct, then the answer will be positive 3/5. So, okay, let me write a note, review sheet. So guys, in the review sheet, the answer is wrong. In the review sheet, I have negative 3/5. The answer is positive 3/5.
Oh, wait, that question on the review sheet, and then you got the wrong.
So, are you sure we have the same sign, plus and minus, in the middle? Yeah, but do you have the same question? Plus middle sign and the minus plus sign. Yeah, then yeah.
I have a question. So when our solution gives 0, we have to put prime.
You said you cannot just take it. For example, do you remember doing the length question, length and width? We got a negative length. What did you tell?
That's not possible.
Exactly. So if you have x equals 0 in a solution, you write not possible. Okay, now, why I was keep telling you to follow my method, follow this method exactly. Now, let me do this using not my method, but a different method, just to show you what's the danger you have if you don't follow my method. Okay? So, if you don't want, don't copy, because I don't want to mess you up. I just want to show you a different method. So in this different method, what people do is people actually don't bring everything to one side. They just get rid of the denominator completely because they hate the denominator. Okay? So remember, if you don't want to write, don't write. But we are going to follow the same step. What is our first step here? The first denominator is not factorable, but the second denominator is? It is factorable, so we write x plus 6, x minus 6. And then let's observe, we have x plus 6 in one group and x plus 6, x minus 6 in another group. So what is our LCD? We see the same thing, so we take x plus 6, and then something different, so we take x minus 6. If it's the same thing with multiple powers, you take the bigger power. But if it's the same thing, just take one of them. So what people like to do is this. We have x over x plus 6, and then 72 x plus 6, x minus 6, plus 4. I would recommend not to copy. Okay? Just this will be in the exam, but I'm going to show you the correct method later. This is not correct method. This is correct, but that will get into trouble. Okay, if you follow this method. So what people like to do is people like to get rid of the denominator. So if you don't want to see denominator, you multiply everything by LCD. All the numerators by LCD. So what happens? You cancel this, and there is no denominator on the right. So you have x with x minus 6 equals to 72, and 4, if you multiply this, you get x squared minus 36. See, one good thing about this method is there's no denominator, but you'll get into trouble later. So we distribute, we get x squared minus 6x, 72 plus 4x squared. What is 36 times 4? Someone in my first class, they told me 144 without doing any math. The answer was correct, 144. And now this becomes simple quadratic equation. So you bring everything to one side with factor. So subtract x squared, add 6x, and these are like terms we combine. So at the end, we get 3x squared plus 6x minus 72 equals 0. All of them are, we have a GCF to factor out, or you can simply divide by 3. So you get x squared plus 2x. What is 72 divided by 3? 24, I remember. So it becomes simple, right? Simple, right? Two numbers multiplied to 24 combined to 2. What are that? 6 and 4, give me the sign. Plus 6 minus 4. So x plus 6 equals 0, x minus 4 equals 0. That gives us x is negative 6 and x is positive 4. Right? Simple, right? But guess what? Let's observe our denominator. The first denominator is x plus 6. We know this cannot be 0 because denominator can never be 0. So we subtract 6. So x cannot be what number? But look, one of the solution is what? 3. So can you accept x equals negative 6 as your solution? No. So this is the delta. This will be multiple choice in the final exam. You'll see both of them. And if you do this method, you're going to circle both of them and you'll be enjoying saying, oh, I got it correct. But guess what? They got it 0. Why? Because it did not check the denominator. This method requires denominator. So I'm not going to do, I'll tell you not to follow this method. Bring everything to one side, simplify, and then you see that this problem will not be there anymore. It will automatically get canceled out. So let's do this correctly using our method. This is not wrong, okay? This is correct. But let's do this using our method and you'll see the difference. We have x over x plus 6 equals 72 x plus 6 x minus 6 plus 4. Now you can start copying. We have this. Remember I said bring everything to one side so you can see 0. So your choice. You can bring left to the right or right to the left. It doesn't matter. Let's say since the left is only one term, let's bring the left to the right. That means we are going to keep our right. 72 over x plus 6, x minus 6 plus 4. And you're subtracting this. So minus x over x plus 6 equals 0. If you want, you can bring the right to the left. So you have to subtract two things. I'm too lazy. So I'm just subtracting one thing. And then we look for our LCD. What's the LCD? We have plus 6 minus 6. So you have to take both of them. X plus 6, x minus 6. And if you compare x plus 6 with x plus 6, it's the same thing. So you don't have to take anything extra. It's same. Okay, so we want this denominator, every denominator. The first one already has it. We are happy. But here below 4, there is no denominator. We want them. X plus 6, x minus 6. So we multiply both numerator and denominator by that. Are we missing anything on the third denominator?
Yeah.
What is missing? So we do x minus 6, x minus 6. So x plus 6 minus 6 plus 6 minus 6 plus 6 minus 6. We have the same thing on denominator. We go for the numerator. We have 72 plus 4x plus 6 minus 6 minus x, x minus 6. And the other side is 0. And now we are going to simplify the numerator. So since we have this, let's multiply this first. We have 72 plus 4 times. What do you get from multiplying x plus 6, x minus 6? Without using FOIL? No. You're multiplying x plus 6, x minus 6. X squared minus 6 squared. Good. These are conjugates. Anytime you multiply conjugates, is the first one squared minus second term squared, which is 36. And let's distribute this because this is easy. What do you get from the distribution? Negative x times x. And then negative x times negative 6. Negative x times negative 6. Positive 6x. Over the denominator, x plus 6, x minus 6. 72. Square is on the top. And now we distribute the 4. So let's go to another page. Page break. We have 0 equals 72 plus 4x squared. And again, 4 times 36. Do you remember? 144. Times. Minus x squared plus 6x over our denominator. X plus 6, x minus 6. Do not multiply the denominator. Do not. Always simplify the numerator, but not the denominator. So comparing x squared and 4x squared, we get 3x squared. We have 72 and 144. What do you have? Negative 72. And then we have 6x alone, so plus 6x. X plus 6, x minus 6. And then we factor. So first we factor out 3. We get x squared plus 2x minus 72. And then we factor this more. So we get x plus 6, x minus 4 over x plus 6, x minus 6 equals 0. And then what do you see? Did I make a mistake?
Yeah.
Oh, this is 24, sorry. When I factor out the 3, it becomes 24. Good catch.
Divide 6 by 3 and put 3x on the other side.
We're not using AC method because A is divisible by everything. So you factor out 3 and in fact AC
So that would be
method.
the GCF.
So yeah, good thing. Let me write this down. GCF and then here direct factoring. And now what do you see if you look at numerator and denominator?
And have the same x plus 6. So
Good. So what do you do?
cancel.
Cancel. So if you use my method, the problem will be solved here. You're going to get rid of all the things that makes the denominator 0. So we left with 3 times x minus 4 over x minus 6 equals 0. And remember I said, forget about the denominator. Only look at the numerator. We have 3 times x minus 4 equals 0. Does 3 have any x next to that? 3 times x, do you have that? So this 3 is useless. We get rid of that by dividing. We have x minus 4 equals 0. And then how do you find x? Adding 4. So x equals 4. Do you have 2 solutions or do you have 1 solution? See, if you simplify fast, you don't have to worry about the denominator. But if you don't simplify, you have to worry about the denominator. So let me tell you what will be in the exam. From the trial and error, one of them. I'm going to give you the choices. You definitely should learn the trial because I'm going to give big numbers like 57, 67, those big numbers. And you must show your work. You cannot guess. One from solving, or maybe 2. We have 2 types, 2 terms and 3 terms. Healthy. So definitely 1 from solving. 1 from the application. Combining 5, 6, and 7. So 5 says simplify. You need the knowledge, NLADG. You need the knowledge of 5 to do 6 and 7. Okay. So 1 from multiplication, 1 from division. But the 5 will be inside multiplication and division. Here. So definitely 2. If I have space, then I'm going to give 3. But definitely 2. Multiplication, division. Now for addition, subtraction, 1 with the same denominator. So we are going to combine the numerator, factor, cancel, rewrite for the same denominator. And 1 from different denominator where numerator will not be factorable. Then for solving, what we did, 1 from these types, x and x squared, and 1 from this type. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Definitely 9, but I'll put more because the more question you have, the less you can, the less point it will have. So if you're 10 times 10 is 100. 1 question must be 10 points. See? So if you get wrong on 1 question, the entire thing is wrong. So I'm going to try to put more questions so that you can lose less points. But definitely 9 to 10 questions. Definitely. A.
Would be like the shirt.
On Thursday, on Tuesday.
Yeah.
Study smart, guys. Working hard doesn't solve all the problem, but working smart solves problem easily.
Oh, yeah, I'll go down to like, I think 7.5. Oh, no, this one. What do you mean by rewrite?
So when you have the same denominator, you're going to combine the numerator directly.
Yeah.
And then you can able to factor that. Once you
Factor
factor, then I'll give you something that you can cancel. Once you cancel, then you whatever remain, you rewrite.
But the denominator, or is it like wait, no?
You're going to factor the denominator. We did this in our last class. Watch the recording.
We just factor everything.
Is it good?